meet at a point and they make a right angle. So we saw that we could name the lines with the letters of the alphabet. So I go here, this line, this I'm going to call line AB, and here I go line CD. Are these perpendicular lines? What do you think? Do they make a right angle? Do they meet at a point? Well, let's check. So AB is perpendicular to CD because they meet at a point and they make a right angle. And I can use my right angle tester to check if they make a right angle. Yes? So AB is perpendicular to CD because they make a right angle. Okay? So today we're going to be learning about other type of lines, but before we're going to mark yesterday's work.
Okay, so we go here, activity 1, circle the pairs of lines that are perpendicular. How did you find that? Was it helpful to look for right angles in order to find perpendicular lines? Let's check. So we know that figures C, D and E make perpendicular lines because these lines meet at a point and they make a right angle. Okay, so we got figures C, D and E. Activity 2. Name the sides that are perpendicular in each shape. Remember, all the lines are already labeled for us, so let's check. So we know that AB is perpendicular to BC because they meet at a point and they make a right angle. Here, did you find any right angles? We know that P and Q and R, PQ and QR make a right angle, so PQ is perpendicular to QR. Also, QR and RS make a right angle here, so QR is perpendicular to RS. KL is perpendicular to LM because they make a right angle here. Please mark the right angles, and that way you will see the lines easily. Okay, so KL is perpendicular to LM because they make a right angle here. LM is perpendicular to MN because they meet at a point and make a right angle here. MN is perpendicular to NK because they meet at a point and they make a right angle here. And KL is perpendicular to LM. Have we done this one already? I think so. Yeah, that was the first one. KL is perpendicular to LM. Okay, so you got four different options. Do not worry if you wrote the letters in a different order. That's fine as long as it makes sense. Okay. Now figure D, we know the ZY is perpendicular to YX because they make a right angle here. We also know the YX is perpendicular to XY because they make a right angle here. We had to write two statements, but there are actually three options, so you could have written that XY was perpendicular to WB because they make a right angle here. Okay, so any of those three options are fine. Do not worry if you wrote it the other way around. And lastly, we had to look at the letters in the word mathematics and complete the table. So we say the letters with no perpendicular lines, we found M, A, C and S because we cannot see any right angles in those letters. There was T with one pair of perpendicular lines, and H, E and I with more than one pair of perpendicular lines. Okay, I saw that you came out with all different answers for B, so well done. We're going to be learning about parallel lines. We're going to start by looking at this picture. What do you notice about the railway track? Is there anything that you noticed here? Remember, yesterday we were learning about perpendicular lines. So what can you see in this picture that you could talk about? How would you describe the iron tracks in comparison to the wooden beams? So if you look at the iron tracks here and the wooden beams here, how could you describe these types of lines? Are the lines perpendicular? Yes, well done. They are, because we know that if we can see a right angle, then we can see perpendicular lines. So this line, this iron track, is perpendicular to this wooden beam because it makes a right angle. And it happens the same in every single one of them, both sides, both iron tracks. Okay? So remember, if we are looking for perpendicular lines, we need to look for right angles. And then we could say that the lines that make the right angle are called perpendicular lines. Now, what about the two iron tracks? So if you pretend the wooden beams are not there, and you just look at the iron tracks, what type of lines are there? Are they perpendicular lines? Do they meet at a point? Do they make a right angle? Have a think. Look at the two iron tracks. Do they meet at a point? Do they make a right angle? Answers. So we can see that the two iron tracks, and I'm giving them the name AB and CD, so you know what I'm talking about when I describe the lines. So AB and CD are not perpendicular lines because they do not meet at a point. Even if we extend them, even if we pretend they keep on going, even if we extend them, they will never meet at a point. So they do not meet at a point. So therefore they do not make a right angle. So these lines that do not meet at a point, they have a special name. Do you know how these lines are called? They are not called perpendicular lines. They are called something else. It's also a long word. Can you guess? Let's find out together. So they are called parallel lines. So my go, parallel lines. Your go. Once more, my go, parallel lines. Your go. So parallel lines are lines that they never meet at a point. So even if you keep drawing the lines and pretend to see how far they will go, they will never meet at a point, and they do not make an angle. They're kind of opposite to each other as well. So if the lines never meet at a point and they do not make an angle, we call those lines parallel lines. Okay, so we go now perpendicular lines, which are the lines that meet the point and make a right angle, and parallel lines, the lines that never meet at a point and they do not make an angle. You can use your hands. Can you use your hands and show me two parallel lines? So two lines that never meet at a point and they do not make an angle. Well done, that's great. Can you now show me two perpendicular lines? So two lines that meet at a point and make a right angle. Show me with your hands. Well done. So today we're going to be learning about parallel lines. Again, show me with your hands. So lines that never meet at a point and they do not make an angle. So we're going to be giving these parallel lines a name as well as we did with the perpendicular lines, just so when we write down our answers it makes sense. Okay, so we will also call it, for example, AB and CD. Okay, so parallel lines never meet at a point and they do not make an angle. We mark them with a little arrow halfway. Can you see here? So we do like a little arrow halfway in order to mark parallel lines. So perpendicular lines, we were not marking them, we were just giving them names. Parallel lines, we give them names, but also we mark them with a small arrow halfway. Okay, so parallel lines are lines that never meet at a point and they do not make an angle. So this is a great example of parallel lines. But these ones, look, here in the picture the lines are not meeting at a point and they are not making an angle. But if I extend the lines, I know that at some point they will meet and they will form an angle. So we cannot call these parallel lines because at some point, if we keep drawing, they will meet at a point. So we need to make sure that the lines never ever meet at a point in order to form an angle. Okay, so they are opposite to each other, they never meet at a point. These are not parallel lines because if I keep drawing, if I extend the lines, at some point they will meet together. Okay, so we need to be careful with that. We don't need to look just for the gap, we need to see, we need to look at if they are going to meet at some point or not. Okay, so parallel lines, they never meet at a point, they do not make an angle, and we mark them with a small arrow. And now is, how many parallel lines can you find around you? This challenge is tricky, so please think carefully. You need to find lines that never meet at a point and they do not make an angle. So pause the video and go and have fun.
Wow, that was a tricky challenge, but you did really well. You're experts. So now we need to identify if there are any parallel lines in these figures. So we're going to start with the orange one. So we know that parallel lines never meet at a point, even if we extend them, and they do not make an angle. So we just looked at it. Do they meet at a point? No. Do they make an angle? No. But what can we do to prove it? We can extend them just to prove it and be sure. So grab a ruler and with a pencil extend your lines to see if they will touch at a point. So I got a ruler. Do you think A, B and C, D will touch at a point? Fantastic, well done. So they will not touch at a point, they will not make an angle, so we could write that AB is parallel to CD. Okay, now let's check our second figure. We've got line LM and line NO. Do they meet at a point? They do not meet at a point. Do they make an angle? They do not make an angle. But how can we prove that they are parallel lines? We can prove it by extending these lines. So grab a ruler and extend your lines. So a ruler and a pencil, one line, and then the other line. What can you see? So I did extend my lines both ways, and now I can see that they will meet at a point and they will make an acute angle. So if they meet at a point and they make an angle, are they parallel lines? Well done, great job! They are not parallel lines because at some point they will meet and they will form an angle.
Now let's look at these two figures. Which sides are parallel? Let's start with the red one. So we got line AB, BC, CD and DA. Now all these lines are meeting at a point, but we need to find the lines that will never touch. So the lines they will never meet at a point and they will not make an angle. Okay, so I know that the lines that are touching each other are not going to be parallel lines because they are meeting at a point. So it could be that they are perpendicular lines but not parallel. So we will have to skip a line to see if those lines are parallel or not. So let's check. So AB cannot be parallel to BC because they are meeting at a point. But let's check AB with not this one but the following. So AB with CD. Do you think AB and CD, we extend them, are they going to meet at a point? So use your rulers and your pencils when you do in your workbooks. So if I extend AB all the way up and DC all the way to the right, will they meet at a point? Well done, they will never meet at a point that way, but let's check the other side. So I'm going to extend AB all the way down here, and I'm going to extend CD all the way across to the left. So do you think AB and CD will meet at a point? Do you think at some point they will meet and form an angle? If you use your rulers later on, it will be easier to see, easier to spot. So I can see that if I keep going down and all the way across to CD, they will touch and make an angle. So AB and CD are not parallel lines. Let's have a look at our last one. So we can do now BC. So BC and DA. So is BC parallel to DA? What do you think? Try to extend the lines. So extend the lines. So I got AD here and I got BC here. Are these lines going to meet at a point? Do you think they will touch at some point? Fantastic, well done. You're doing really well. So we know that BC and AD or DA are parallel lines because they will never meet at a point. So we will have to write it down here. So we'll have to do BC is parallel to AD, or BC is parallel to DA. Are there any other lines in this figure that are parallel? No, you're right, we checked them all. So here we just got BC and DA as parallel lines. Let's check our last figure. An easy way to see parallel lines is if you think of like opposites. So what is in front of? Okay, so that way you will know that if it is in front of you, it probably not always won't touch you. Okay, so think about that, but it is not a rule because here we can see that these lines are touching each other, okay, and they start more or less in opposite sides. So let's have a look. EF. Can EF be parallel to FG? No, because they're meeting at a point and parallel lines never meet at a point. What have we got? What line is there in front of EF? So in front of EF we have HJ or GH. So we could say, if we extend these lines, so follow the red pointer, look, it goes all across the screen, one line, and then I'm going to the other one, to one side, and then to the other. These lines will never meet at a point. Okay, so these lines, these two lines, will never meet at a point, so therefore we could say that EF is parallel to GH, because they will never meet at a point and they will not make an angle. Are there any other pairs of lines that are parallel in this figure? So we've checked EF, FG and GH. So we got another set to check. So we could do HE and EF. We know that they are not parallel because they touch the point. So we could do HE and GF. Now remember the tip that I gave you before. They're kind of opposite. They're opposite to each other, and they are in front of. So HE is in front of GF. So we can stand these lines and check. Do you think they will meet at a point? Fantastic, well done, you're working really hard. So we could say the HE is parallel to GF, because even if we extend them, and please do extend them in your workbooks, even if you extend them, they will never meet at a point. Well done. Before we move on to our workbooks, I'm going to ask you to complete this challenge. So which letters have parallel lines? So remember, parallel lines, they never meet at a point, even if you extend them, and they do not make an angle. So if you see letters that make an angle and all the lines meet at a point, then you are going to know straight away that there are no parallel lines there. But you need to look for lines that will never meet at a point and they will not make an angle. So pause the video, write this word in capital letters and try to find as many parallel lines as possible. Please upload your findings to Class Dojo so Miss Dani and I can check how wonderful you are. Come on, let's go, 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 you can do it, go! How did you find today's lesson? I think parallel lines are a bit trickier to find than perpendicular lines. So please, if you need help, let Miss Downing or myself know and we will give you a hand, okay? So your word for today is going to be finding parallel lines. So we have to do pages 165 to 168. So it looks exactly the same as the work you did yesterday, but if you read the activities, it says that we need to find parallel lines, okay? So we are not finding perpendicular lines, we're finding parallel lines. Lines that never meet at a point, even if you extend them. So those lines will never make an angle. So in activity 1, you need to circle the pairs of lines that are parallel. Please feel free to use a ruler and a pencil if you want to extend your lines and check if they will meet or not. Activity 2 and 3, you need to name the pairs of lines on each figure or shape and write down your answer. So you could say, I think EF is parallel to CD because they never meet at a point and they do not make an angle. So if you think that's right, you could write that here. Or you could say, I think EF is parallel to GH. EF is parallel to GH because they never meet at a point and they do not make an angle, okay? So you need to do the same in activity 2 and 3. Here you need to name the pairs of lines that are parallel. Here you need to name the sides that are parallel on each shape. But again, you're using the letters to write down your answers. And finally, you need to look at this word, examination, and find the letters that have no parallel lines, one pair of parallel lines, or more than one pair of parallel lines. Lines that never meet at a point and they do not make an angle. Again, here you need to write another letter that is not here above, that has parallel lines. Okay, so we would like you to upload today's work to Class Dojo so we can see how you're getting on, and just to check if you need a bit more help or if you're confident with it. Please feel free to write when you upload your work how you felt about it. Okay, if you think that is quite tricky, do let us know. If you think you're okay, then let us know as well. Okay, have fun. Bye. Our challenge today is pizza challenge. So your challenge today is to recap all the contents that you've learned this week and show us. So you need to first of all bake a pizza, put it in the oven, heat it up so it's ready to eat. Then you need to cut your pizza so you make an obtuse angle. So you need to cut your pizza making an obtuse angle, an angle that is larger than 90 degrees. Then cut that angle and make it a right angle. So from an obtuse angle you want to cut it and make it a right angle. Once you are happy with your result, cut it again and make it an acute angle. An angle that is smaller than a right angle. You've also got 2 questions to answer. You could cut your pizza again if you wanted to. So can you cut your pizza so there are perpendicular lines? This one, think about it really carefully, because we know that if we can find the right angle, then we can find, well done, we can find perpendicular lines. And your last question is, can you cut it so there are any parallel lines? Okay, so have a go and make sure you have a lovely supper or lunch. If you do not want to use a pizza, you could do your challenge with an omelette or something similar. It's up to you, or you could even use a piece of paper if you want it. Okay, so next week Miss Dawn is going to be with you. Have a lovely weekend. We miss you all. Bye.